friends, welcome you all to Think Max. We are in class 11 Max, chapter 10, conic sections. In this session, we are going to discuss the shapes involved in this chapter, its general equation, and some small formulas. Okay, so how we get the shapes from the cone and different type of shapes, their general equation. So those are the some basic concepts involved in this conic sections. So we will be studying those basic concepts in this chapter. Okay, so if we just learn those formulas, this chapter will be very simple. Okay, now let us consider this cone, which is in the shape of an ice cream cone. Here you have three shapes, not three shapes, four shapes: circle, ellipse, parabola, and hyperbola. These are the four shapes we are going to learn in this chapter. So, in this shape, that is in this cone, if we cut the cone here, straight line, then you will get circle. Okay, so that is if you cone this cut here, you will get the shape of a circle at the base. Okay, so you will get the circle when you cut the cone here. Now, if you cut the cone in this way, then you get the shape of the ellipse. So this is the oval shape is the shape of the ellipse. Now if you cut the cone here, this way, then you get the shape of a parabola. So this blue color is the shape of a parabola. Now if you cut the cone in this way, okay, if you cut the cone here, you will get the shape of a hyperbola. That orange one is the shape of the hyperbola. Now we are going to study these shapes. Okay. So before studying this, we should know some names in the cone. So let us learn that. Now this is the axis. Let us take this as an axis. Now I am going to draw another line. This line is called the generator. Now if I rotate this line, we will get a cone. So if you are rotating this line, you will get a cone on top as well as in the base. So let us see. See, you will get a shape of this cone. Okay, so this line is called the axis, this vertical line is called the axis, and this slanting line is called the generator. So we will be rotating this line, so you will get a cone on the top as well as in the base. So now let us name this line, vertical line, is called the axis. It is denoted by L, and this slanting line is called the generator, through which we rotate, and it is denoted by M, and it is called the generator. Now the angle made by the axis and the generator is denoted by alpha. Okay. Now here two cones meet. There is a cone in the top as well as in the base. So here the two cones meet. So here it is meeting. So this point is called the vertex, and it is denoted by V. Now this vertex separates the cone into two. Here there is a upper one and lower one. Now we call this upper part as upper nap and the lower cone as lower nap. Okay. So let us name that. So this is called the upper nap and this one is called the lower nap. So these are the basic words you have to learn. So this vertical line is called the axis and the line which rotates is called the generator. So when you are rotating, we will get two cones on top and base, and it has a meeting point in the middle. The point is called the vertex and it is denoted as V. The angle made by the axis and the generator is denoted as alpha. So we get two cones, one on the top and one on the base. So upper one is called the upper nap and lower one is lower nap. So these are the basic things you have to learn in conic sections. Now, in the next page, we will be learning how the circle, ellipse, parabola and hyperbola are generated using angle. Just I showed you how we can draw lines. Now, what does this angle make with this vertical axis? Okay, so let us learn that in the next page. Yes. Now this we all know. Circle is here, ellipse is here, and the parabola is here, and the hyperbola is here. Okay. Now here when beta is equal to 90 degrees, that means we get, if we draw a line like this, the angle made by this line and the axis, which is denoted as L, is denoted by beta. So this beta will make 90 degrees. So if you cut here, you will get circle shape. So when beta is equal to 90 degree, the shape is circle. Okay. So now let me erase this. When alpha less than beta less than 90 degree, that is if you cut this way. Okay, if you cut this way, this angle is beta. Now, if alpha is less than beta and this beta is less than 90, that is beta should be greater than alpha. If it is so, then we will get the shape of the ellipse. Okay, so here we have. So if we cut in a slanting position, then we will get the shape of the ellipse. So now the condition for the angle is this beta should be greater than alpha and this beta should be less than 90 degree. Then we will get the shape of the ellipse. Next one is parabola. How to get the shape of the parabola? It is very simple. We have a generator here. Okay. If we cut parallel to the generator, if we cut parallel to the generator. So this is the line that cuts. Here X is parallel to the generator M. Then we will get the shape of a parabola. So as both are parallel, this angle beta will be equal to alpha because X is parallel to M. If they are parallel, alpha and beta are called corresponding angles. So alpha will be equal to beta, then we will get the shape of a parabola. Okay, so these are the three shapes. Now the last shape is hyperbola. So just to check how the hyperbola cuts. So this is the way the hyperbola cuts. So this is the angle made by the hyperbola, which is beta. Here beta will be greater than or equal to 0 but less than alpha. So in hyperbola, this line cuts both the upper nap as well as the lower lip. So and it will give the shape of the hyperbola. So this is the way we get those four shapes: circle, ellipse, parabola and hyperbola. So we'll get those four shapes. When beta is equal to 90 degree, it is a circle. When beta is less than 90 and greater than alpha, it is an ellipse. When both the values alpha and beta are equal, then it is a parabola. When beta is greater than or equal to 0 but less than alpha, then it is a hyperbola. In hyperbola, the line cuts both the upper nap as well as the lower nap. So these are the shapes we get. Now we are going to study the shape of a circle, which we will be doing in the next page. Yes. What is a circle? A circle is the set of all points in a plane that are equidistant from a fixed point in the plane. So in cone, we get this circle when beta is 90 degree. Okay, when beta is equal to 90 degree, we will get the shape of a circle. Now what is a circle? So just we will have the axis y axis and x axis and a circle. Now what is a circle? Is a set of all points in a plane that are equidistant from a fixed point. So let us fix a point C. Okay. Let us fix a point C. If we take a point in the plane P1, P2, P3, P4, P5 and draw lines between this P1, P2, P3, P4, their distance will be same. Okay, CP1, CP2, CP3, CP4, CP5 will be of equal distance. If it is so and we join these points, we will get a circle. So, circle is the set of all points in a plane that are equidistant from a fixed point. This fixed point is called the center of the circle. Okay. Now, so this is the center point. Let us have the center point at h comma k and there is a point in the circle P which is at x comma y. The distance between C and P, that is from the center of the circle to the circumference of the circle. That distance is called the radius and we denote it by r. Now, we have to find the equation of the circle. It is very simple. Already we learned the distance. Equation of the circle, we find it using the radius value. So, this radius is nothing but distance between C and P. So, radius is nothing but distance between C and P. So we have to use the distance formula. So what is the distance formula? It is nothing but square root of x2 minus x1 the whole square. Here x2 is x. X minus x1 is h. X minus h the whole square plus y2 minus y1. So y2 is y minus y1 is k. Y minus k the whole square. So what is the distance? Distance is nothing but radius. So radius is denoted by r. So r is equal to square root of x minus h whole square plus y minus k the whole square. If we square on both sides, we will get r square equal to, when squaring this root gets cancelled. So it will be x minus h the whole square plus y minus k the whole square. So this is the equation of circle. Clear? It is very important and you have to remember this formula. R square equal to x minus h the whole square plus y minus k the whole square. Here R is the radius of the circle. X and y are points in the circle and h comma k is the point of center. So the center point value is h comma k. So this is called the equation of the circle. And here C is the fixed point and this is the point in the plane. Okay. So these are the things you have to learn in the circle and the important equation which is this r square equal to x minus h whole square plus y minus k whole square is the equation of the circle. Clear? So shall we move on to ellipse? So ellipse is here. We will be learning about ellipse in the next page. Yes. So what is ellipse? Ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. Okay. Now, let us take those two fixed points, F1, F2. We call this as focus. And 2 points in the plane as P1, P2. Okay. Now I am going to join F1 and F2 with P1. Okay. So I have joined F1 and F2 with P1 and I am going to join F1 and F2 with P2. Okay. So if it is so, what is the condition? Is the set of all points in a plane. So this P1, P2 are the set of all points in a plane. The sum of whose distances from two fixed points. So sum of the distances. That is, take the white line F1 P1 plus F2 P1. Okay. So sum of the whose distances from two fixed point in a plane is constant. That is, they are same. So this distance will be equal to the distance of another point. That is F1 P2 plus F2 P1. Adding the yellow lines. Okay. So this is the definition for ellipse. Now we will derive the equation of the ellipse. So this is the shape of the ellipse. We will get the shape when we cut the cone here. That is when alpha is less than beta, less than 90 degree. Okay. So this is the angle condition for ellipse. Now we will have two axes. Okay. So let us have the x-axis and y-axis. Let us name the vertex this as A and let this be B, this be C, D. So these are the vertex. Here this is a long line. X-axis has long. So this AB is called the major axis. And CD is smaller than this. So CD is called the minor axis. Okay. AB is called the major axis and CD is called the minor axis. Now let us take the focus. Focus as F1 and F2 and this point as origin. The point where major axis and minor axis meets is the center point. So this OF1 and OF2 will be of same distance. Let us name this as C. In the same way, the distance between OC and OD will also be same. Let us name that as B. And the distance between A and O and O and B will also be same. Let us name this as E. So we got OA equal to OB equal to A. Then OC equal to OD is equal to B. Then the focus OF1 equal to OF2 is equal to C. Then if it is so, then equation of the ellipse is, general equation of the ellipse is x square by a square plus y square by b square equal to 1. So this is the general equation of the ellipse. This x and y are points on the ellipse. The point A will be x comma y, or B will be x comma y, C will be x comma y, or D will be x comma y. So x and y are points on ellipse. The value of A and B is here. The value of A is the distance between O and A or O and B. And the B is the distance between the O and C or O and D. Okay. So this is the equation of the ellipse. Now we should know eccentricity and lattice rectum. Okay. So eccentricity is denoted by E. It is nothing but C by A. So the C is nothing but distance between O and focus F1. Okay. So E is equal to C by A. Next one is lattice rectum. So lattice rectum is nothing but If this is the ellipse and we have the major axis and minor axis and we write focus here, the line passing through the focus is called the lattice rectum. So its value is 2b square by a. Okay, clear? So these are the formulas. That is general equation x square by a square plus y square by b square equal to 1. This is the general equation of the ellipse. Eccentricity is equal to c by a and lattice rectum equal to 2b square by a. So these are the things already derived. Okay. No need to study the derivation which will not be asked in the exams. Just you have to know what is the general equation of the ellipse, eccentricity and the formula for lattice rectum. If you know these three formulas, you can do all the problems. Clear? So these are the things you have to learn in ellipse. Okay. So in the next page, we will learn about parabola. Okay. So what is a parabola? A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point. This fixed point will be not on the line in the plane. Okay. So now let us learn what is a parabola. So we will have a parabola. This is the shape of a parabola, mouth open. Okay. And here this is called focus and this is the axis, x-axis and y-axis. Okay. We have x-axis and y-axis and this is the focus. The point where the parabola meets the axis is called the vertex and this line is called the directrix. Okay. So these are the things in a parabola. Now we should know how this directrix is related to parabola. This directrix, if you check the distance between this and the distance between the vertex and the focus will be same. So this line will be the directrix line will be parallel to this line. Okay. So this is called the lattice rectum. It will be parallel and it will be in the opposite side of the axis. Okay. So this is the directrix. Now we should learn how this directrix is related to parabola. Okay. So now if you take a point P1, P2, P3 in the parabola and points B1, B2, B3 in the directrix. Now the focus is here. If you have, what is the definition? It's the set of all points in a plane that are equidistant from a fixed line. This is the fixed line and a fixed point. So this point is equidistant from this fixed line B1, B2, B3 as well as the focus. That is the distance between B1, P1 and P1F will be same, which is written here. So P1F will be equal to P1B1. In the same way, P2F will be equal to P2B2 and P3F will be equal to P3B3. So this is the relationship of directrix with the parabola. That is the set of all points. Who is that point? P1, P2, P3. They are the set of all points in a plane that are equidistant. So the distance between the point in the fixed line. The fixed line is nothing but directrix. So the distance between B1, P1 that are equidistant from a fixed line and a fixed point. Fixed point is nothing but focus. So FP1. So this is the relationship of directrix with the parabola. Okay. So now we learned what are the terms involved in this parabola. Now we should learn the standard equations of the parabola. So it is in the next page. So there are four forms of a parabola. Okay. Now let us take this. first form. This is the first form. In this first form, you can have the parabola mouth open in positive side of x-axis. Now we have the focus here. The directrix is at x is equal to minus e, that is negative side. Parabola is in positive side of x-axis. This focus will be at a comma 0. If it is a comma 0, positive a comma 0, then the directrix will be at negative side of a. That is x is equal to minus a. This is the equation of the directrix. Then for this type, the equation of the parabola is y square equal to 4ax. This is the equation of the parabola with focus at a comma 0. Okay, this is the first form. Second form. So second form, when the parabola mouth is open in the negative side of x-axis. So therefore the focus is at minus a comma 0. Then the directrix will be at a comma 0. That is the directrix will pass through a comma 0. That is x is equal to a is the equation of the directrix. Then the equation of the parabola is y square equal to minus 4ax. Y square equal to minus 4ax. This is the equation of the parabola. Clear? Next, third one. In this, the parabola mouth is open in the positive side of y-axis. So therefore, the focus will be at 0, comma a. Then the directrix will be negative side of y-axis. That is y is equal to minus a. So this is the directrix. Then the equation of the parabola is x square equal to 4ay. This is the equation of the parabola. Okay, clear? Next, fourth one. Here, the parabola mouth will be wide open in the negative side of y-axis. Therefore, the focus will be 0, comma minus e. So, here the focus is in y-axis. In y-axis, x value will be 0. So, focus will be 0, comma minus e. Then the directrix will be at positive side of y-axis. So, its equation is y is equal to a. Then the equation of the parabola is x square equal to minus 4ay. So these are the four equations of the parabola. So one is y square equal to 4ax. When the mouth of the parabola is open in the positive side of x-axis, the focus will be a comma 0. So a is a point on x. In x-axis, y value will be 0. So the focus will be at a comma 0. If it is focus is at positive a, then the directrix will be x is equal to minus a. Then equation of the parabola is y square equal to 4ax. In the same way, if the mouth is open at the negative side, then the focus will be minus a comma 0. Negative side of x-axis, and y coordinate will be 0 in x-axis. So therefore the equation will be y square equal to minus 4ax. Okay. Now if the parabola is mouth is wide open in positive side of y-axis. So in y-axis, x coordinate will be 0. So f will be 0, comma a. So then the equation is x square equal to 4ay. If it is in y-axis, then you start with x. X square equal to 4ay is the equation of the parabola. Now the last one, if the parabola is wide open in negative side of y-axis, the focus will be 0, comma minus a, and the directrix will be y is equal to a. Then the equation of the parabola is x square equal to minus 4ay. So these are the four standard forms of a parabola. Clear? So just remember the four standard forms equation. So that is enough. Derivation is not needed. Now we have to study the lattice rectum. So what is a lattice rectum? It is nothing but, now if you have the parabola here and you have the focus here, the line passing through the focus is called the lattice rectum. Okay, so lattice rectum is, so this is AB. AF value is 2A and these are equal. So totally lattice rectum is nothing but AB. So AB is 2A plus 2A, which is 4A. So lattice rectum is 4A. Okay. So these are the things you have to learn in parabola. So standard forms of the parabola and lattice rectum value. These are the things you have to learn in parabola. So and the last one is hyperbola. Okay. So the hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. So this is same as the ellipse. In ellipse, sum of the distances. In hyperbola, it is the difference. Okay. So just we can learn the standard equations of the hyperbola. So in hyperbola, you have x-axis and y-axis. This x-axis is called the transverse axis. Okay, this is called the transverse axis and y-axis is called the conjugate axis. Okay, so this is called the conjugate axis and this point is the vertex a comma 0 and this is the focus which is at c comma 0 and this is origin and there is another part here and this is at, I'm sorry, minus a comma 0 and this vertex and the focus, another focus f1, f2. F2 is at minus c comma 0. Okay, clear? Now, this vertex can be named as A and this vertex can be named as B. So, the distance between OA and OB is A. Okay, and the distance between the O and focus, OF1 and OF2 is C. Then if it is so, the equation of the hyperbola is x square by a square minus y square by b square equal to 1. So this is the equation of the hyperbola where the mouth is open in x-axis. Now suppose if the mouth is open in y-axis. So this is the vertex. We can name it as A, which is at 0 comma A. So as it is in y-axis, x coordinate will be 0 and y coordinate we name it as A. And the focus is at 0 comma C. Now let us name this point as B. It is 0 comma minus A and the focus F2 is at 0 comma minus C. And if it is so, then the equation of the hyperbola is y square by a square minus x square by b square equal to 1. So this is the equation of the hyperbola. Clear? Now we have named AC. We got AC. Now what about this B? So this B is related as B square equal to C square minus A square. This is the relationship between A, B and C. So we can get the value of B square from C and A. So you can get B as square root of C square minus A square. Okay, so you have to remember the equation of the hyperbola. When the mouth is wide open in x-axis, it is x square by a square minus y square by b square equal to 1, where b square equal to c square minus a square. So if the mouth is wide open in y-axis, then the equation of the hyperbola is y square by a square minus x square by b square equal to 1, where b square equal to c square minus a square. Okay. So now in the same way, we should know what is eccentricity and lattice rectum. So here eccentricity is nothing but, it is denoted by a, is nothing but c by a. And here lattice rectum also same as the ellipse, which is 2b square by a. So eccentricity is c by a, lattice rectum is 2b square by a. So these are the formulas you have to learn. Now you should know the value of eccentricity, lattice rectum, and the equation of the hyperbola in x-axis and in y-axis. If you learn all these formulas, you can do all the problems with ease. I think I have explained all the concepts involved in the conic section. If I have any missed any concepts, you can comment me. Also, if you are not able to understand, just you can tell me in comments. Okay. If you like my video, just show your support by subscribing to Think Max. Okay. Thank you. Thank you for watching.